Hi, my name is Anova Abidin. So I'm going to present about the analysis of variance Anova. So basically, Anova used to compare the means of two or more population groups. Anova derives its name from the fact that we are analyzing variances in the data. Anova measures variation between groups relative to variation within groups. Each of the population groups is assumed to come from a normally distributed population. So, the assumption of Anova is the M group or factor levels being studied represent population whose outcome measures, firstly, are randomly and independently obtained, second, are normally distributed and have equal variances. If these assumptions are violated, then the level of significance and the power of the test can be affected. Now, I'm going to illustrate to you on how to do the Anova question. So the question is, using the data in the Excel file freshman college data, use Anova to determine whether significant differences exist in the mean retention rate for the different college over the 4-year period. Second, use Anova to determine if significant differences exist in the mean ACT and SAT scores among the different colleges. First, we must conduct the hypothesis. So for the rationale is significant differences in the mean retention rate for the different college over 4-year period is not exist. So the H1 you can just copy and put is exists. Basically, we have three data analyses. For the first one, we use first year retention rate. For the second one, we use ACT and then SAT. For the first one, we sort it using first year retention rate. So we just copy the liberal arts and then the music, then the education, engineering, business, architecture, North Central Brand Campus, nursing, then for vocational, for South Central, and lastly is health science. Then we go to the data and click data analysis and choose Anova single factor. So the input range, we highlight all and then tick the label, and output range is at here, and then click OK. Then we take the two-tailed test chart and include the F value and F crit value. So the conclusion for the first data analysis is as F test value of positive negative 10.77 and false in the rejection region, the p-value of 0.00 is less than alpha of 0.05. So we reject the H null. Therefore, there is significant differences exist in the mean retention rate for the different college over the 4-year period. For the second data analysis, we take the average ACT data and sort it out just like before. And then we go to the data and click data analysis and choose Anova single factor. And then for the input range, we highlight these all. And then take the label output range here and click OK. Then we take the two-tailed chart and include the F value and the F crit value. So for the conclusion for the second data analysis is, as F test value of positive negative 110.61 and false in the rejection region, the p-value of 0.00 is less than alpha of 0.05. So we reject the hash null. Therefore, there is significant differences exist in mean SAT score for the different college. For the last data analysis, we take the average SAT data. Then after we sort it out, we click the data and make the data analysis and choose Anova single factor. And for the input range, highlight all and tick the label. For the output range, click here, then click OK. Then we make the chart and include the F value and the F crit value. So the conclusion for the last data analysis is, as F test value of positive negative 126.99 and false in the rejection region, the p-value of 0.00 is less than alpha of 0.05. So we reject the hash null. Therefore, there is significant differences exist in the mean ACT score for the different college. For the overall conclusion for the three data analysis is, there is at least one mean is different from others in the mean retention rate for the different college over the 4-year period, and the mean ACT and SAT scores among the different college. That's all from me. Thank you.